Hello all. Today we will discuss about pointers and arrays. Array name by itself is an address or pointer and it points to the address of the first element. Let me give the example for the same. For example, I have one array and which has the value like, for example, 32, 54, 65, 23, 66, 43, 68, 76, 25 and 48. Now I'm just simply printing over here percentage d, and whenever you print the name of array, it will print the address of the first element, and whenever you write pointer arr, then it will print the value at the first address. So whenever you write pointer arr, it will print the 32, and whenever you print the arr, it will print the address of the 32. That is the address of the first element. So whenever you run this, build and run, here you will be able to see that this is the address of the first element, that is 32, and this is the value. It means that array by default itself is an address or a pointer. Now what is the wonderful advantage? For example, if you are writing over here, that is arr plus 3, then it will point to fourth value, that is, you can say at the third index starting from 0. So 0, 1, 2 and 3. So it will point to the element, that is 23. It means it will print the address of 23. Now if you want the value at that particular address, then you can write arr plus 3 and then you can write the pointer. So what happened in this case? This arr is pointing to first address plus 3. It means 0, 1, 2 and 3. Then it will give me the address of 23 and the value 23 over here. So whenever you build and run, here you will get the address of 23 over here and the value 23 over here. It means that array plus, and if you add the index over here, and simply it returns the address, and if you want the value, then you can write the star. Using indirection operator, you can get the value. Now I want to know that how I can access the value of array in the different way. So very simple, you can write percentage d. If you are writing arr of 0, then it will print 32. If you are writing 0 of arr, then also it will print 32. Now suppose if you are writing arr plus 0, then it will give me the address of 32. And if I am writing over here, that is pointer arr plus 0, then it will give me the value over here, so 32. Now if you are writing 0 plus arr, then also it will give me the element, that is 32. So these are the four ways to access the value of array. Using pointer you can do this, and you can directly write the element. You can access the element writing like this: arr of 0, it will give me the first value. 0 of arr, then also it will give me the first value. If I am adding the arr plus 0, then it will give me the address, and if I am pointing to that address, then it will give me the value, that is 32. If I am writing 0 plus arr, then also it points to the first element, and here whenever you write star, you will get the value. So these are the four ways to extract the element from array. Now I want to create here, I want to demonstrate you one simple example, and that is what I want to here declare one pointer variable, and using the pointer I want to access each and every element from array. Can we? Yes, you can. See here, simply I am declaring the variable integer pointer p. Now I am declaring one more variable, that is I, to iterate each and every element for the array. So I am simply writing here for I equal to 0, I less than 10, I plus plus. Now what happens, students? Please see carefully. Suppose if you are writing printf percentage d, and if you are printing over here, now my pointer is pointing to the first element, that is arr. So ARR is returning me simply the address of the first element, that is 32. So my pointer is pointing to the first element, that is 32. Now I am just simply printing percentage %d and percentage %d. So if I am printing P and star P, then what happened? It will print the address of first element, that is the address of 32, and star P will print the value, that is 32. If you run this 10 times, then 10 times it will print the same address and same value, that is 32. So every time I am getting the address and value. If you put /n over here, then you will get the proper output and you will get the idea that every time I am getting the same result, that is the address and value at the first element. Now pointer has a power to point the any address. So if you simply write here P++, then pointer will simply point to the next address after one loop. Then it will point to the next address, and up to 10 times whenever you run this, pointer will point to each address and each value. See here 32, 54, 65 and up to 48. I'm accessing all the elements of array using the pointer. And once you are able to access the array element using the pointer, you can develop the different kinds of program. Now I want to give you the simple demonstration, and that is what I want to find it out the maximum from array using the pointer. How we can do this? Let me save this program as demo2.c. So I want to simply find it out the max. So I'm simply declaring one variable, that is max. Now what we can do over here, max is equal to pointer P. Now P is pointing to first element first. So pointer P means 32. So 32 will be assigned in a maximum variable. And here you can simply print this. Printf maximum is equal to percentage %d, and you can print the max. So what happened in this case, it will print the maximum is equal to 32. Why? Because I am simply assigning the first element as a max. Now I want to check if any element from array is greater than the max. If any element is the greater than the max, then the maximum is that particular element. So how we can do this? Simple. You can write here if pointer P, it means any element is greater than the max, then the max is equal to pointer P. So what happened in this particular case? If any element is greater than the maximum element, right now maximum is assigned with the 32. So next element is 54. Is 54 is greater than the 32? Yes. Then the max is equal to 54. Up to it not find the another maximum number, the maximum will get that particular number, and at the last you will get that the maximum is equal to 76. So what happened in this case? Simple. First, P is equal to ARR, it means pointer is pointing to the first address, and max is equal to pointer P, it means max is pointing to the value 32. Now any value is greater than the 32, then the max will be that particular value, and that is the reason why 76 is the maximum from this array, and that is the maximum value. Now I don't want only maximum, it means maximum has the address, that is this. It means I want the maximum element as well as I want the maximum value address. So how we can access the address? So very simple. If you want the address, and at that time to store the address, we can declare the pointer variable. So I'm simply declaring one more pointer variable over here, and that is pointer Q. Now what will be the role of pointer Q? Simple. If any element is greater than the max, then the value will be assigned. If any element is greater than the max, then the value assigned will be assigned to the max, and we want the address to be assigned to the Q. So I'm simply assigning Q is equal to P. So what happened? I can simply access the address also. Maximum is equal to this and address is equal to this. You can simply print the Q and you will get the result. Whenever you run this, you will get the idea that the 76 is the maximum and the address of the 76 is 6356708 and that is available over here. What I did? Simple. If any number is greater than the max, then that number will be stored into max variable and the address of that number will be stored into q variable, and q is the variable that is pointer. So whenever you print the q, it will simply print the address. But sometimes people says that, sir, should we need to declare the separate variable for this? Can we do the same thing with the max variable and that we can declare as a pointer? Yes, you can do. Let me save this particular program as demo3.c. Now what I want to do? Simple. I don't want to declare the pointer q, but I want to store the value in pointer max. It means whenever, see here, the maximum is 76. So I want to store the address of 76 into max. So whenever I print the max, it will simply print the address. And whenever I print the pointer max, it will print the 76. That is what I want to do. So whenever you want to do like this, very simple in this particular case, what we need to see carefully. Now this max is the pointer variable. So we will not assign the value, but we will assign the address. So instead of assigning the value, we will simply write here max is equal to P. So what happened? Max is pointing to the P and P has the address that is first. It means max has the address of first element. Now, if P pointer P, so pointer P will point to which number? 32. So if pointer P is greater than the pointer max, max is now my pointer variable. So max has the address of 32, and if you write pointer max, then it will simply retrieve the value over here. So if pointer P is greater than the pointer max, then what we need to do? Simple. Instead of writing the value and instead of maintaining the value and address separately, we can simply write here max is equal to P. So what happened? Your pointer address will be stored into max. So what happened in this particular case? Simple. If you print the max, then it will print the address, and if you print the pointer max, then it will print the value. You can simply run this and you can check this program has declared only one variable instead of maintaining the P and Q separately, max and Q separately. You can declare the variable max as a pointer, and see here 76 is found at this address, that is 6356712. Here you can check, yes, 76 is found at this particular address. What I did? Simple. I just declare the one variable pointer and another variable max. Both are pointing to the first element. If any value is greater than the maximum, then the address of that value will be stored into max. And if you have the address, you can simply write max, then it will simply print the address. And if you write over here pointer max, then it will print the value. If you run this, then you can check that what happens. See, maximum is equal to this and address is equal to this. Why? Because I just make the mistake over here. Maximum is equal to %d. I need to write pointer max over here, and I need to write max over here. So whenever you run this, it will simply print maximum is equal to 76 and address is equal to this. And at this address, the 76 is available. Now, I want to develop the simple program, and that program is what? I want to find it out the first highest, second highest, and third highest from the array. And I also want the address of the same also. It means, can we do the program that retrieve the address of the first highest, second highest, and third highest? Yes. For that, we need to declare first highest, second highest, and third highest three variable as a pointer. So let me save this particular program. I'm saving this program demo 4. Now, instead of this max, I want the first max, I want the second max, and I want the third max. So we want the three maximum value, first highest, second highest, and third highest. So what we can do over here, definitely my pointer will point to the first element over here. Now I am writing here, instead of assigning pointer to max, we can simply write here first max is equal to second max is equal to third max is equal to ARR. It means all these three maximum will point to the first address, that is 32. So address of 32 will be assigned in a first max, second max, third max, and all this, right? You can simply cut this, and instead of this maximum, you can simply print fmax pointer and fmax address. You can simply write here, this is the first maximum. Now here you can write second maximum is equal to percentage D, and I want the address is equal to percentage D pointer second max and second max. Here you can simply put one space so it will look little bit good. Now I'm writing here printf. I want the third max. So third maximum is equal to percentage D, and address of third maximum is equal to percentage D. So to print the value, you can write pointer Tmax, and to print the address, you can write Tmax. So address will be printed over here. After all these statements, we can simply put new line. And here, let me give one space. Now, whenever you run this, what happens? See, your first element will be pointed by all these three numbers. It means fmax will point to the first address, smax will point to the first address, tmax will point to the first address, and as a result, I will get over here result is, that means all are pointing to the same value, that is 32. So first maximum is 32, second maximum is 32, and third maximum is 32. And this is the address of the 32. Now I want to write the loop and I want to access the element. How we can access the element? Simple. You can write here for I equal to 0, I less than 10, I plus plus. I want to iterate and I want to get each and every element. So I'm simply writing here printf percentage D slash n. If you write here p, then it will print the address, and if you write pointer p, then it will print the value, and you can simply iterate the value p plus plus. So what happened? All the element will be displayed over here with the address, but at last first is 32 and this is the address. So it means this address is displayed at the first maximum, second maximum, and third maximum. Why? Because I have not given any condition yet. Now here you can give the condition. For example, if pointer p, it means p is pointing to every time a new value in the array. So if pointer p is greater than the pointer f max, it means if the pointer p is greater than the first maximum, then I will definitely make that the first maximum is equal to p. But before this, my first maximum should be stored into second maximum. So second maximum is equal to first max. But before assigning the second maximum, I need to write third maximum is equal to second maximum. So what happened? Your third maximum variable have the value, and that is, but I will simply assign the address. Why? Because once I have the address, I can get the value easily. It means if I am getting the address of first max, then if I want the value, I can simply write pointer f max and I can get the value. But if pointer p is not greater than first max, but pointer p is greater than the second max, then you can write else if pointer p greater than pointer second max. If my pointer p value is greater than the second maximum, then Definitely second maximum is equal to pointer, but before this we need to write third maximum is equal to second maximum. Why I am not using the pointer over here? Just because I want the address of the second maximum, first maximum and third maximum. So I'm simply getting the address. Once I get the address, I can simply get the value. Else if pointer p is greater than the pointer t max, it means if pointer p is not greater than the first max, pointer p is not greater than the second max, but pointer p is greater than the third max. If it is greater than the third max, then you can simply write t max is equal to p, and as a result what happens? See, your all value will be processed if any pointer value is greater than the first maximum, then that first maximum has that address. But before that, that first maximum address will be assigned to second maximum, and second maximum address will be with the third maximum. And as a result, whenever you print first maximum, that is pointer f max, it will print the value, and whenever you print f max, it will print the address. You can simply build and run this particular program, and you will get the output that the first highest is the 76, and it is available at this particular location 704, and second maximum is the 68. It is available at the 700 location, and the third maximum is the 66 over here, and it is available at the location that is 692. So this is the way you can deal with the array and pointer. That's it from my side. If you like this video, then please like, share and subscribe to my channel. Thank you all.